The rapid pace and complexity of Arctic change demand new and strengthened Arctic adaptation and global reductions of fossil fuel pollution. The Arctic continues to warm at a faster rate than the global average. The 2024 Arctic Report Card highlights record-breaking and near-record-breaking observations that demonstrate dramatic change, including Arctic tundra transformation from carbon sink to carbon source, declines of previously large inland caribou herds, and increasing winter precipitation. Observations also reveal regional differences that make local and regional experiences of environmental change highly variable for people, plants, and animals. Adaptation is increasingly necessary, and indigenous knowledge and community-led research programs are essential to understand and respond to rapid Arctic changes. Headlines. In the air. Arctic annual surface air temperatures rank second warmest since 1900. Autumn 2023 and summer 2024 were especially warm across the Arctic, with temperatures ranking second and third warmest, respectively. An early August 2024 heatwave set all-time record daily temperatures in several northern Alaska and Canada communities. The last 9 years are the 9 warmest on record in the Arctic. Summer 2024 across the Arctic was the wettest on record. Arctic precipitation has shown an increasing trend from 1950 through 2024, with the most pronounced increases occurring in winter. In the ocean. In September 2024, the extent of sea ice, which has a profound influence on the Arctic environment, was the 6th lowest in the 45-year satellite record. All 18 of the lowest September minimum ice extents have occurred in the last 18 years. Arctic Ocean regions that are ice-free in August have been warming at a rate of 0.5 degrees Fahrenheit (0.3 degrees Celsius) per decade since 1982. In most of the shallow seas that ring the Arctic Ocean, August mean sea surface temperatures were 3.6 to 7.2 degrees Fahrenheit, 2 to 4 degrees Celsius. Warmer than 1991 to 2020 averages, though the Chukchi Sea was 1.8 to 7.2 degrees Fahrenheit, 1 to 4 degrees Celsius. Cooler than average. Long-term ocean primary productivity plankton blooms continue to increase in all Arctic regions, except for the Pacific Arctic, throughout the observational record of 2003 to 24. However, in 2024, lower than average values were dominant across much of the Arctic. Ice seal populations remain healthy in the Pacific Arctic, though the ringed seal diet is shifting from Arctic cod to saffron cod with warming waters. On land. When including the impact of increased wildfire activity, the Arctic tundra region has shifted from storing carbon in the soil to becoming a carbon dioxide source. Circumpolar wildfire emissions have averaged 207 million tons of carbon per year since 2003. The Arctic remains a consistent methane source. Alaskan permafrost temperatures were the second warmest on record. Warmer temperatures impact caribou movements and survival through direct summer heat and changes in winter snow and ice conditions, with regional variations in population declines and recoveries. Arctic migratory tundra caribou populations have declined by 65% over the last 2 to 3 decades. While the generally smaller coastal herds of the western Arctic have seen some recovery over roughly the last decade, previously large inland herds are continuing a long-term decline or remain at the lowest populations noted by indigenous elders. Summer heat impacts on caribou herds are projected to increase over the next 25 to 75 years, requiring shared knowledge between scientists and northern communities for management strategies. Snow accumulation during the 2023-24 winter was above average across both the Eurasian and North American Arctic. Despite above-average snow accumulation, the snow season was the shortest in 26 years over portions of central and eastern Arctic Canada. Arctic snow melt is occurring 1 to 2 weeks earlier than historical conditions throughout May and June. Greenland ice sheet mass loss lowest since 2013. Tundra greenness, a measure of expanding tundra vegetation cover and biomass due to warming temperatures, ranks second highest in the 25-year satellite record. Indigenous knowledge and partnerships. Indigenous hunters are the original researchers of their homelands, with observation and monitoring skills integral to traditional practices. The Ituk Heritage and Research Centre in Kangikchugapik, Clyde River, Nunavut, Canada operates the Anganay program, teaching traditional hunting and harvesting to new generations. Supporting Indigenous leadership in Arctic research requires sustained support of Indigenous ways of life and knowledge generation.